Hello, this is Mr. White, and this video is on fundamental trigonometric identities. Yay, we're in a new chapter. Booyah, we're still doing trigonometry, but you knew that. We were not done with trigonometric fun. This chapter is called Analytic Trigonometry, and although this chapter title suggests that we're going to move into some distinctly new phase of trig, the truth is we're just going to be continuing a journey that we already began in the last chapter. Once we started moving beyond the mere SOHCAHTOA and we started analyzing the unit circle on the XY plane and we transitioned to sinusoids and other trig curves, we were already stepping into analytic territory. I'm not going to try to explain thoroughly what the word analytic implies. You'll find out soon enough. But here's the best single piece of advice I can give you as we proceed on our trig journey. You've got to see the interconnectedness of everything that we're doing now, which is going to start with something called trig identities, and everything we've done before. And I don't mean just this year, I mean previous years as well. Of course you have to remember the SOHCAHTOA. The inverse trig we did recently, yes, you need to know that. S equals R theta, you're going to need to know that as well. Everything that we've been doing is going to just kind of play a role in how we proceed. And that's one of the more difficult aspects of this topic. You better be solid on your algebra. You better remember a few things from geometry class. And I don't mean the more obscure things. I mean some fairly major things, fortunately, that major themes from geometry. So you need to see that all these puzzle pieces are linked together. And then it won't feel like you're just on some new remote deserted island. You're going to see that the algebra that you learned before helps out. The fractions help out. SOHCAHTOA plays a role. It all supports each other. So later on in this chapter, when we have to solve equations that look kind of ugly and scary like this, once you look at that and you go, oh, I have something squared minus a constant times that same something plus another constant. That kind of reminds me of a quadratic equation. Well, yes, it is a quadratic equation, and all the stuff you learned in Algebra 2 about quadratics still applies. When it comes time to say what this angle actually is, you better know your unit circle if they're special angles, and you better know your inverse trig if you have to solve for a not-so-special angle. We're also going to be asked to simplify some expressions. So when you see an expression like this, and it's big and scary and unwieldy to deal with, you're going to find that very often these can be simplified into something neat and concise. But in order to do that, you better know that when you're adding a fraction to another fraction, we need to deal with these denominators and make them common. So you better bring out your fraction skills. All of this is interconnected, and all those old skills will help make the stuff seem less scary if you see the interconnectedness. Okay? Keep that in mind. Let's start with fundamental identities. That's what this first section is about. And first of all, what is an identity? When you think identity, think of the word identical. Unlike an equation in which you're given a variable and you're asked to solve for this variable, certainly not all values of x will make this equation true. Only certain values would, and you need to find them. That's an equation. But identity says this equation is true for all values of x. I can plug any x value into this equation and it will be true. The only little caveat is that you're not allowed to make, or if a value makes one of the sides undefined, well, we'll still call it an identity, but we'll just accept that it's not true for that case. Let me give you a real quick example. I'm going to make up a really boring identity. 5 times x minus 3 over x minus 3 equals 5. There it is. There's my identity. Well, we can see that that's true for almost every value of x. The only value of x that's going to cause problems is 3 because it makes the left side undefined. So again, come back to this statement. It made the left side undefined. The right side is still 5. Therefore, this is not a true equation, but we'll still call it an identity in spite of that one little exception. All right, so here's our first identities, and the good news is you already know some of these. You already know cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent, and by extension, you should know that sine, cosine, and tangent are the reciprocals of, are equal to 1 over cosecant, 1 over secant, 1 over cotangent, respectively. The second one's here, the quotient identities. I think we brought them up in class. We didn't really belabor it. I said we'd go into more detail later. Tangent and cotangent, you should be able to look at or envision the unit circle. And you should recall from previous lessons that when you have a true unit circle where this hypotenuse is equal to 1, the radius of the circle really is 1, you should remember that x coordinate was equal to cosine of theta and the y coordinate was equal to sine. And you should be able to make sense out of why that is. And once you've accepted that and you say, yes, that makes sense, we look at that and say, tangent of theta is opposite over adjacent. That's opposite sine theta over adjacent cosine theta. And guess what? That is our first quotient identity. So tangent of theta is equal to sine over cosine of theta. Cotangent, in a similar fashion, is equal to cosine over sine. Those are quotient identities. They need to make sense to you. All right, the next set of identities also come from the same unit circle. And I just somewhat arbitrarily said, let me draw the angle over here in the third quadrant. But the implication is really that this is true no matter what quadrant we're dealing with. And I would hope that when you think back to your geometry studies, you could just look at that picture on the screen and predict what these next identities are going to say. Think about what you know about right triangles way back from years ago and look at that picture. And you should be able to predict that this next set of identities, which is called the Pythagorean identities, would tell us that this leg squared plus this leg squared equals hypotenuse squared. When you think back and think of the interconnectedness of trig back to geometry, that first Pythagorean identity should not be a surprise. That's just a Pythagorean theorem in disguise. Now, the second two, I don't blame you if you're a little bit puzzled as to what other two we could have. But let me make the claim that as long as you got that first one down and it makes perfect sense, the second two are very easy to come by. And I often have students say, I don't remember the other two. And I say, well, so what? Figure them out. They're not hard. Here's how I back up that claim. If I take that first one and I divide by cosine squared of theta, one term, I need to divide all terms by cosine squared of theta. And then I say, well, clearly cosine squared over cosine squared of theta is going to equal just 1. Sine over cosine, both of them squared. Don't let it fool you. Sometimes students haven't seen this as quickly as I thought they might. Remember, that's just the same as sine theta over cosine theta in parentheses. They're both being squared, right? So do you remember from those quotient identities, sine over cosine, that equals what? Tangent, you say? Of course, it equals tangent of theta, just from the previous slide. So I'm going to erase this for space, but you see where I'm going. This is going to be tangent squared of theta. And the last one, by similar reasoning, the reciprocal of cosine is secant, so the reciprocal of cosine squared is secant squared of theta. And that is our second Pythagorean identity. In a similar manner, instead of dividing by cosine squared, we could divide by sine squared. And I'm not going to take the time to do that in detail. I hope and trust you can finish that thought on your own and see how we get our third one. So if ever in the future you say, I don't remember these Pythagorean or the second and third one, don't be offended if I tell you to figure it out. I'm just asking that you use this kind of reasoning and stuff that you already know. All right, there are more identities in this section alone, and that's only the first section in the book. I'm not going to take the time in this video to try to cover these other ones, but just be aware there's a long list of identities to be had. And if you see how they all work and they make sense, it won't seem so intimidating. Okay, first example. Find cosine theta and cotangent of theta if sine of theta equals 1/7 and tangent of theta is less than 0. Your first thought, haven't we done this already? Yes, we have. We typically draw the XY plane and draw the bow tie and such. And I'm going to be perfectly honest with you. I like that way better. I just do. And you probably will too. So if you're wondering, why do I need to learn this new way? Well, you need to learn your trig identities. And this is a good place to practice them. And there are some problems that we'll encounter in the future where your only option will be to use those trig identities, so you really want to practice them now. Okay, for this type of problem, this may seem excessive, but I've found over the years that this is the best way to approach it. Even though it only asks us to find these 2 trig identities, just make a list and put all 6 of them. And we'll just fill in the blanks and look at the interconnectedness between those identities. All right, so let's fill in what we know. We know sine of theta is 1/7. That was given to us. So what do we do from here? I'm not given any of the others. Well, I'm going to think of my first Pythagorean identity. My first Pythagorean identity tells me that sine squared of theta plus cosine squared of theta equals 1, right? So let's plug in that value of sine that we are given and use it to figure out cosine. I'm going to do that fairly quickly. This is algebra that you should feel comfortable with. But as always, if I lose you or you have a question, I really ask that you come see me. All right, so 1/7 squared, that's just 1/49th, right? And this over here is 49/49. So again, I'm going a little bit quickly, trusting that your arithmetic skills will keep up. Cosine squared of theta equals 49/49 minus 1/49. That's going to be 48/49. And if you need to write it out on paper, by all means do so. I'm just trying to go a little quicker here. And actually, instead of putting an equal sign there, I'm going to take the square root of both sides now. And here's a common mistake. A lot of students will just put cosine of theta equals square root of 48 over square root of 49. Instead of square root of 49, let's call that 7. And instead of square root of 48, let's simplify that. Call it 4 root 3. But here's the mistake. They just stop right there. Excuse me. We need to ask ourselves, is it the plus or is it the minus? Because remember, anytime that you introduce a square root sign into a process, you must consider the plus or minus. So, question. How do we figure out whether the cosine is the plus or the minus? Well, I'm going to put that on hold for just a second, and I'm going to erase some of this. I hope you've written that down and that it all makes sense. I'm going to just put over here plus or minus 4 square root of 3 over 7, and I'll come back and I'll correct it later once I figure out which one it is. But I'm going to go to my quotient identities. So let me come over here. Tangent of theta is less than 0. Remember the quotient identity that says tangent of theta equals sine of theta over cosine of theta? Well, this equation is telling us that, or this inequality is telling us that tangent is negative. We already know that sine right there is positive. And so what must the sign of cosine be? Well, positive over positive isn't going to work here, so cosine must be negative. Does that make sense? Good. So if cosine is negative, I can come back over to my answer and say definitively this is negative. All right, let's see. We were asked to find cosine, so I just got that done. I need to find cotangent. So cotangent is just the reciprocal of tangent, and as I just put up there, the quotient identity is going to be our key to doing that. So let me just continue here. I've got sine of theta is 1/7. And if you're wondering, couldn't I use the quotient identity for cotangent? Of course you could. I just had this on the board already, so let me run with it. And that's a negative sign. All right, you should be comfortable with your fractions. Comfortable enough to say 7 and 7 cancel out. Okay, that's what tangent of theta equals. And remember, I don't really care if you rationalize your denominator as long as you can recognize in the answer key when your answer differs from the books, when they're the same thing. Okay, we were asked to find cotangent. Well, since cotangent is the reciprocal of tangent, I look over at my value for tangent and I say cotangent is negative 4 root 3. And you know what? Even though I haven't completed my table, I have done the two that I was asked for. And my solutions are right here and right here. I'll go ahead and call this example done. And I'll trust that you could figure out the remaining two if you need to. If you're good with that, go ahead and do the last example, or go ahead and skip to the end of the video and try the exercise on your own. Just in case anybody needs me to do another one, let me do it here. So again, I repeat, if you feel comfortable with that, skip to the end, to the last minute or so, try it on your own. But let me do one more for those that may need another showing. All right, once again, I'm going to start by bringing out my table and fill in what I know. In this case, we see that cosecant of theta is negative 1.5. I strongly encourage you to get comfortable with fractions, improper fractions as well. Some of you are going to disagree with me, but I just ask that you trust my experience here that fractions are going to be more helpful in the long run here. All right, what else do I know? I didn't do this in the last example. I'm not sure why it slipped my mind, but let's use the reciprocal identities. Cosecant is negative 3 over 2. Well, sine must be negative 2 over 3, right? Piece of cake. That wasn't what we were asked, but again, maybe that'll come in handy. All right, let's go to the Pythagorean identity, and I want the one that involves cosecant. You don't remember that one? Well, figure it out the way I showed you, right? That one said that 1 plus cotangent squared of theta equals cosecant squared of theta. And since I know cosecant squared of theta is negative 3/2, and I know negative 3/2 squared is positive 9/4, I'll start with that. I'm going to subtract 1 over here on the left side of the equation. Technically, I should put a minus 1 here and here. But over here on the right, rather than just subtract 1, I'm going to subtract 4/4, just as a bit of a shortcut. I hope you don't mind. And that leaves me with cotangent squared of theta equals 9/4 minus 4/4, 5/4. Again, let me erase some of this. I try to keep the print large enough so that those viewing this on a mobile device can see what we're doing, but unfortunately I end up having to erase my work a lot. All right, do you remember the little caveat? Do you remember what's wrong with me just saying cotangent of theta equals square root of 5 over square root of 4? And instead of square root of 4, I'll write 2. But again, I'm still missing something. Do you remember what it is? Oh, that's right, the plus or minus. Whenever you introduce a radical sign, you've got to do the plus or minus. So plus or minus root 5 over 2. I'm going to put that in, plus or minus root 5 over 2, and try to figure it out. I'm going to try to do it's easy at this point. And remember how the reciprocal identities are probably the easiest ones to apply. I know what cotangent is, so therefore I know that tangent is just going to be the reciprocal. And once again, I haven't figured out the sign yet, but I'll put plus or minus 2 over root 5. And let's go back to our quotient identities, because here's the game plan. My quotient identity is going to help me figure out cosine, and then once I have cosine, I'll be able to easily figure out secant. So again, this is the reason why I found it easier just to make this table. Allows us to just fill in what's easiest at any given time. Okay? Let's proceed this way. Let's go to the quotient identity that says that tangent of theta equals sine over cosine. I'm going to rearrange that, and you're going to need to be comfortable rearranging these identities. I need you to be able to comfortably say that cosine of theta as a result equals sine over tangent of theta. I need you to be able to rearrange fractions comfortably enough to see that. And the reason I did that is because I know sine, I know tangent, I want to know cosine, so this rewriting of the formula will help me figure it out. So let's plug in the sine and the tangent that we have so far. Sine is negative 2 over 3 of theta. tangent is plus or minus 2 over root 5. Be careful in trying to cancel these out. That is going to give us negative 2 over 3 times the reciprocal, root 5 over plus or minus 2. The 2's cancel out. That gives me negative root 5 over 3. And it's really a plus or minus. So here's where I'm finally going to say, you know what? I don't need to worry about all this plus or minus. I'm going to look at this. That's what tells me that I want the positive value. So let's put positive root 5 over 3. And I can finally figure out that plus or minus, those unresolved plus or minuses. Since tangent is sine over cosine, and I see that sine is negative and cosine is positive, that tells me that tangent is going to be negative. And therefore, its reciprocal cotangent will be negative. So if you're wondering how do I keep all this straight, this is sort of a big jumbled mess, there's not any one way to do it. But again, writing this table, considering all those identities that you have in mind, I think you'll find that you can fill them in easier than you think you could. So finally, secant is the reciprocal cosine. Therefore, this is positive 3 over root 5. And I was asked for secant and tangent. There's my secant. There's my tangent. As a bonus, gave all the other values too. All right. Again, if that seemed jumbled and you're not sure you can figure out how to do it, I ask that you write the table of all the 6 trig functions. Just think of the basic identities that were introduced here, the Pythagorean identities, the quotient and reciprocal identities, and just kind of cycle this through your head and think, which one can I use right now? Okay, here are the activities for you to try. Good luck. Pause the video at this point. Okay, trusting you've done your duty here. I'm not going to put all 6 trig functions up there. I'm just going to put the ones that were asked for. And again, if you simplified them in some way that I didn't, I expect that you'll be able to figure out if your answer really is the same as mine. If any of that didn't make sense, please come take care of that as soon as possible before things get even trickier.